So here we're going to look at the solution to the first practice problem using Manning's equation. And the first thing to know about these problems is that they're really not hard. They're just basically a matter of plugging into the equation and turning the crank and getting the answers. So Manning's equation can be written as follows. The velocity, this is the average velocity in a stream, equals, in the metric system, we're going to be using the metric system here. It actually depends on whether you're using the metric system or the English system, the equation you use. It's equal to 1 over n is the roughness coefficient, times the hydraulic radius to the 2/3 power, times the square root of the slope of the stream, the gradient of the stream. So it's just a matter of finding what these parameters are and plugging into the equation. So let's start with the roughness coefficient n. If we read the description of the stream, it says it's the main stream, main drainage, and it flows in a winding channel with some pools and shoals and a few weeds and stones. So if we go to the chart, here it is reproduced. It's a main channel. It's got winding with some pools and shoals, but it also has some weeds and stones. So we're going to use 1D. We're going to estimate the Manning coefficient as 1D. And you're giving 3 rows here. In general, unless you have any reason otherwise, just pick the normal value. So the normal value here is 0.045, and that's the value that I'm going to use. So I'm going to say that the roughness coefficient n is equal to 0.045. Okay, let's do the next easy one here, the slope of the stream. The slope is a dimensionless number that is the fall divided by the distance. In this case, we say it's got a gradient. It loses 90 centimeters per kilometer. Now, these are not in the same units, so we have to put them in the same units to calculate the dimensionless slope. So 90 centimeters is the same as, if you remember, there are 100 centimeters per meter. So this is the same as 0.9 meters per kilometer, which is 1,000 meters. And so that will give us a slope of 0.0009. Okay, so we've got the Manning coefficient, the roughness coefficient, we've got the slope, and the only kind of tedious part of this problem is to calculate the hydraulic radius. So the hydraulic radius is defined as the area of the channel divided by the wetted perimeter. The wetted perimeter is the part of the channel that's in contact with solid. So it would consist, in our case here, this is our channel, it consists of this part of it here. So we have to figure out the area of this thing, and we have to figure out the length of that red line. And this is just making use of some identities of triangles that you might remember. So for the red line, there are two pieces that look like this here, right? And we want this length here, and that's just a Pythagorean theorem, right? So we can write that x here is equal to the square root of this squared and that squared. 5.5 meters squared plus 2.3 meters squared, and that is 5.96 meters. 5.96 meters. And we need 2 of those, right? Because there's one for each half triangle here. So the total wetted perimeter is equal to 2 of these, 2 times 5.96, or 11.92 meters. The area of the triangle, now this is actually really easy. The formula for the area of a triangle here is equal to the half of the base times the height. Well, we already know both of these numbers. The base is 11 and half is 5.5, so it's 5.5 meters times the height, and we know the height, it's 2.3 meters. So we just need to multiply those things together, and we get 12.65 square meters. So this is the area here. This is the wetted perimeter. That's the area. That's the wetted perimeter here. And to get the hydraulic radius, we simply divide the area by the wetted perimeter, as I show here. So this is going to be equal to 12.65 square meters divided by 11.92 meters. You see it's going to be a little bit more than 1 meter, and the actual answer is 1.06 meters. So there you go. So now it's just a matter of plugging into our equation. We have everything we need. We just calculate, put all these values in here, and turn the crank, and we get 0.69, and this will be in terms of meters per second. So N was 0.045, S was 0.0009, and the hydraulic radius was a little more than 1. There it was there. So plugging those values into my equation, I get a average velocity of 0.69 meters per second.